This video, we're going to talk about 8.3 Objective 3, which is going to solve problems of joint variation using the constant of variation. So joint variation is when more than one variable, the output depends on more than one variable for input. So like area is equal to length times width, right? And so if the length gets bigger, the area gets bigger. If the width gets bigger, the area gets bigger. It's jointly dependent on both the length and the width. So we didn't talk about a type of variation called inverse variation here, and you may run into those in real life where there are some things where as one thing gets bigger, the other thing gets smaller, but we're not going to talk about that right now. We're going to talk about direct variation and joint variation. And so if y varies jointly with x and z, I get a formula y equals k x z, like that. Using that constant k, we're going to say find y when x equals 3, z equals 5, and the constant of variation is 7. Then y is going to be 7 times 3, should be 5. 21 times 5 is y equals 105. Capital Z varies jointly as w and y, like that. If z equals 360, w equals 15, y equals 8. Let's find k. So 360 equals 120k, and k is equal to 3. Now we're going to go to situation number 2, and we're going to say z equals 3 w y. It's an equal sign. We've replaced the k with its constant value, and we want to find z when w is 70 and y is 10. So z equals 3 times 700 is equal to 2100, 2100. Okay, another thing that varies jointly is going to be simple interest, where I is equal to PRT. We know that formula probably. I varies jointly with R and T based off of the principal K is going to be our constant of variation. So let's go ahead and write this formula here. For I is going to be equal to 1100 times the interest rate as a decimal, 0.035 times T is 5. And we have 1100 times 0.035 times 5. And we're going to get $192.50 in interest is going to be owed on that. That's probably a loan. And that's going to be it for chapter 8. That's all that we're going to cover right now. So we'll come back and talk about our next objective in our next video. So see you for the next video.